Today, we're going to be learning about the Pythagorean Theorem and its converse. Our objectives, we will be able to use the Pythagorean Theorem to find the lengths of sides of a right triangle and use the Pythagorean converse to classify triangles as acute, obtuse, or right. So, the Pythagorean Theorem is c squared equals a squared plus b squared. We need to remember that the hypotenuse is the longest side and is represented by the letter C. Wherever the right angle is, we go across from that, and that is our hypotenuse, and that is our side C. A and B are the legs of the triangle, and it doesn't matter which one you label A and which one you label B. Remember that it's used to solve for the length of an unknown side in a right triangle. This can only be used with right triangles. So what if we wanted to find the value of x in this triangle? We could use the Pythagorean theorem, but sometimes there's a shortcut. There are sets of 3 positive integers that form a right triangle. These are called Pythagorean triples. And if you're able to remember some of these, they can help be a shortcut in problems. So some examples of Pythagorean triples, and there are an infinite number of these that work, but some are 3, 4, 5. Another would be 5, 12, and 13. 7, 24, and 25, or 8, 15, and 17. So because we have the sides of 12 and 5, that means the hypotenuse must be 13, so x would equal 13, and it's a lot less work for us. So checking at the beginning to see if something is a Pythagorean theorem can help shorten the work we need to do for the problem. If you don't remember the triples, it's okay because you can still use the Pythagorean theorem to find the answer. So let's look at some examples. We're going to try to find x. So 12 and 16. Those are both multiples of 4. Do we see that in our triple? No, we don't. So we're going to have to use the whole Pythagorean theorem. Remember that go across from the right angle, that's C, and we'll make this one A and this one B. So C squared would be x squared equals A squared plus B squared. To avoid making any mistakes, I suggest typing this whole right-hand side into the calculator all at once. We don't have any x's, so we can just type the whole thing. 12 squared plus 16 squared gives us 400. So we know that x squared equals 400. Then we need to undo the square, so we're going to square root both sides. We get that x equals the square root of 400. Now we need to simplify this the best we can. So we need to see if 400 is a perfect square. So let's see, square root of 400, not 4,000, 400, and it comes out to 20. So it was a perfect square. So x equals 20, and that's all we need to do. Let's try another one. Across from the right angle is our C side, and then A and B. So 6 squared equals x squared plus 2 square roots of 2 squared. Now many of you probably know that 6 squared is 36 equals x squared plus, now I'm sure most of you don't know the square of 2 square roots of 2. Technically what we do is we square the 2, which would be 4, and we square the square root of 4, we square the square root of 2, which would give us 2. 4 times 2 is 8. But you can also do it on your calculator as long as you properly use parentheses. So if we put parentheses 2 square roots of 2, arrow out of our square root, close our parentheses, and then put the squared on the outside, it'll square this for us, and we get 8. You just have to make sure you have parentheses around the whole thing that we're squaring. Now we need to get x squared by itself. So I'm going to subtract 8 on both sides, and we get 28 equals x squared. Square root both sides. So we get x equals the square root of 28. Now let's see if that's a perfect square. Square root of 28. It comes out to a decimal, so it's not a perfect square. So we need to simplify it using perfect squares. The biggest perfect square 28 is divisible by is 4, and 28 is 4 times 7. Square root both things. X equals the square root of 4 is 2. And the square root of 7 is a decimal, so we're just going to leave it as square root of 7. So our final simplified answer would be 2 square roots of 7. Let's look at one where we have two triangles stuck together. So we are trying to find x in this triangle here. And that's our C side because it's across from the right angle. But we don't know what this side is. Maybe this triangle can help us. We have a 24 and a 25. Let's look back at our triples. Were 24 and 25 in one of the triples? They were, this one right here. Let's double check that 25, since it's the biggest, is the hypotenuse in that triangle. It is the hypotenuse, so that must mean that this mystery side is 7. So knowing the Pythagorean theorems can cut out some work, because otherwise we would have had to do the Pythagorean theorem twice in this problem. So now let's set it up to solve for our x. X squared equals the square root of 26 squared plus 7 squared. Since our x squared is by itself and our right-hand side doesn't have any variables, we can type the whole thing into our calculator. So parentheses, square root of 26 squared plus 7 squared. And we get 75. Square root both sides. X equals the square root of 75. 75 is not a perfect square, so we need to simplify it. The biggest perfect square that goes into 75 would be 25, and 75 is 25 times 3. So x equals, the square root of 25 is 5, square roots of 3. Then find the length of the diagonal of the square. So the diagonal goes from corner to corner across the middle. We want to find that side. So since it's across from the right angle, that's our C. So x squared equals 5 squared plus 5 squared. 5 squared is 25. 25 plus 25 would give us 50. Square root both sides. X equals the square root of 50, which is not a perfect square, so we're going to break it down into the square root of 25 and the square root of 2. So x equals 5 square roots of 2. Now let's talk about the Pythagorean Theorem converse. Do the following side lengths describe a right triangle? And it gives us the sides of 12, 16, and 20. And this is what we're going to use the Pythagorean converse for. This states if c squared equals a squared plus b squared, then the triangle is a right triangle. So we want to check here. Does 20 squared, because that's the longest of the three sides, equal, I'm going to put a question mark because we don't know yet, 12 squared plus 16 squared? 20 squared is 400. I'll leave this blank for whether it equals or it doesn't equals. And then let's find 12 squared plus 16 squared. It also came out to 400. They were equal. So therefore, yes, 12, 16, and 20 form a right triangle. So we just saw that for it to form a right triangle, c squared must equal a squared plus b squared. If c squared is less than a squared plus b squared, then it's an acute triangle. Acute means smaller than 90 degrees, and c squared is smaller than a squared plus b squared. For it to be an obtuse triangle, c squared must be greater than a squared plus b squared. Remember, obtuse is larger than 90 degrees, and c squared is larger than a squared plus b squared. So let's check out the following triangles and see if these side lengths would make a right, an acute, or an obtuse triangle. So the first thing we need to determine is which side length is the longest. Now, do you guys know what the square root of 56 is? Because I don't off the top of my head. So let's use our calculator and find out. Square root of 56 is about 7.48. So based on that, we know that 9 is our longest side. So 9 squared. I'm going to draw the box like we had above because we don't know whether it's equal, less than, or greater than. 5 squared plus the square root of 56 squared. 9 squared would be 81. Then let's do 5 squared plus parentheses square root of 56 squared. That gives us 81. Therefore, they're equal, and it is a right triangle. Let's see which of one of these, square root of 4, square root of 6, or square root of 5, is the largest. Square root of 4 gives us 2. Square root of 6 is 2.449, and the square root of 5 is 2.23. So the square root of 6 is our largest. Square root of 6 squared, square root of 4 squared, plus the square root of 5 squared. Do you know what the square root of 6 squared is going to give us? Square and square root undo each other, so this is just going to be 6. Square root of 4 squared would just be 4. Square root of 5 squared would just be 5. 4 plus 5 is 9. Therefore, c squared is less than a squared plus b squared, so this makes an acute triangle. And if we have sides of 7, 2, and 8, 8 is our largest side, so 8 squared, and then 7 squared plus 2 squared. 8 squared is 64. 7 squared plus 2 squared would give us 53. Therefore, the c squared side is greater, and this makes an obtuse triangle. For our last example, for this one, we're going to use the coordinate plane. So graph the triangle, find the side lengths, round to the nearest hundredth. Then use the Pythagorean converse to classify the triangle as right, acute, or obtuse. So first, let's draw our triangle. Vertex E is at 0, 0. Vertex F is at 2, 4. And G is at 6, 2. Let's draw our triangle. All right, so to find EF, if you recall, our distance formula is the square root of the change in x squared plus the change in y squared. So it just means how much we go in the x direction, how much we go in the y direction. So it's going to be the square root. How much do we go in the x direction from E to F? Well, we go over 2, so 2 squared, plus in the y direction we go up 4. 2 squared plus 4 squared. Since it says to round to the nearest hundredth, we know decimals are okay. So square root of 2 squared plus 4 squared, which gives us 4.47235955. Now, let's look back at the instructions. It said round to the nearest hundredth. What does hundredth mean? That means 2 decimal places. So we get 4.47. Actually, you know what? To make things easier in a little bit, we're going to make this the square root of 2 squared is 4, and 4 squared is 16. 4 plus 16 is the square root of 20, which gave us 4.47. Next, we're going to find FG. So from F to G, we go 1, 2, 3, 4 places in the x direction, plus 2 spaces in the y direction. 4 squared is 16, plus 2 squared is 20. So we get the square root of 20 again, which will still be 4.47. And then finally, E to G. In the x direction, we go 1, 2, 3, 4, 5, 6 spaces. Plus 2 spaces in the y direction. 6 squared is 36, plus 2 squared is 4, which gives us the square root of 40. Let's see what that is as a decimal. Gives us 6.32. And the reason the decimals are helpful is because to determine if it's right, acute, or obtuse, we're going to have to do the Pythagorean theorem converse, and we need to know which side is the longest. So square root of 40 is our longest side. So square root of 40 squared, and we want to know if it's equal, less than, or greater than square root of 20 squared plus square root of 20 squared. Square root of 40 squared is just 40. Square root of 20 squared would be 20. Square root of 20 squared would be 20 also. So we'd have 20 plus 20. So 40. 20 plus 20 is 40. So it's equal, which means we have what kind of triangle? That's right, triangle EFG is a right triangle. For your summary, what is the difference between using the Pythagorean theorem and the converse? Meaning, what do we want to find when we use the Pythagorean theorem, and what do we want to find when we use the Pythagorean converse? That's all for today. I'll see you in class.